thought I could use it.
Oh yeah, doing the job.
You figured it out? There's no one else showing up, I guess. Are we ready? Okay, what is this? Week 13. This is week 13, Thursday. We're finishing statistical quality control, not process control. I gotta fix that. Statistical quality control. Then on Tuesday of next week is the very last lecture on confidence intervals. And then we start the exam a week from today, part 1. And then the part 2 of the exam will be on the following Tuesday, the 12th at 11:30. So 11 a.m. normal a week from today, but 11:30 when the real exam date is on the 12th. Last day to hand in late assignments is Tuesday. So look and see if you got any zeros at all, and open up the answers and handwrite the answers and send me a picture. Get it in this weekend. Let me see, what else do I have on here? Where is it? Oh, here's something I posted if you look in the module for this week, at the very bottom, you're gonna see practice problems. So it goes back all the way to week 5. So problems from week 5, 6, 7, 8, 9, 9 just says pivot tables, 10, 11, 12, and 13, and I don't know what week that's from. I can't remember, because I moved things around from last semester. So you have all of these practice problems, which I believe all of them have answers in the back of the book. If for some reason there isn't an answer in the back of the book, feel free to email me and I'll email you the answers to any of these you need. So you have a lot of practice problems you can work on. Let's see, what else? Here's week 13 instructions. I know I had something at the bottom here. Reminder, last day to submit missing items is on Tuesday the 5th. After that, it's an additional 50% off. Reminder that part 1 of the exam's on Thursday the 7th, a week from today at 11 a.m. Part 2 will be on the 12th at 11:30 a.m. That's all the reminders. Okay. So, what are we talking about today? We are talking about, did anybody, I know a couple of you started the homework. Did anybody else start the homework that came in recently? You started it also? A couple of you started it? Okay. Tuesday's equation was all about finding the upper and lower control limit when there's a standard deviation involved. That was all about Tuesday. Today is all about finding the upper and lower limit when there is no standard deviation involved, because it's a proportion, a percentage or proportion is being given instead with a sample size. So this is that formula. Here, the door's locked?
Yeah, locked us out, that's why we were late.
Yeah. Man. Well, remind me to give this back on the way out. You don't need it right now. You guys, when you're leaving, make sure I give you this stuff. So, after we learn how to manually find the upper and lower control limit using proportion, then it's using Excel to find the upper and lower control limit using either proportion or standard deviation. This is probably the hardest part of this week's lecture, is getting everybody to understand this. But I simplified it to a point to where it shouldn't be too bad. Here's the hard part. That first number in the parentheses. I want you to, when we get to this part, I really want everybody to put on super focus right here, because this is the part that's going to be where you fall apart a little bit on the exam. What? On the exam? When's that? This Saturday? Just check. All right. Is the Big Ten championship football game this Saturday, or is it my imagination?
Saturday.
It is this Saturday?
Yeah.
Okay, just check. Who quarterbacks?
What's
Just check. All right. Huh? What?
You're the quarterback?
Might not.
Really? Imagine, it's actually
Just for the
JJ
day.
McCarthy.
No, they don't have a new coach, you mean, compared to last week?
Yeah.
Yeah, that's true. You're right, back
The
in.
Ohio State coach.
What?
The Ohio State coach.
Who? Oh, yeah, right. Yeah. You guys are too young to remember, Ohio State had a famous coach named Woody, something Woody, I can't remember his name. He was so famous, he was so into the game that he would grab players and hit them with their fist. He got in trouble for it, but that was That was a lot of space. Woody Hayes. Any questions about what to do? Let's look at the homework. You have 5 problems if you haven't started. What I'm gonna ask you real quick is, as I read these problems, I want you to tell me, do you think you're using Tuesday's equation, or do you think you're gonna use today's equation? All right? Number 1 says a random sample of 64 is taken of a normally distributed population with a mean of 116, standard deviation of 22. Show details calculating your upper and lower control limits. Tuesday or today? I hear Tuesday. Everybody agree? Why Tuesdays?
Because it's a standard deviation.
Because there's a standard deviation. That's exactly it. 2 is writing the Excel equation to solve the problem above. Are we going to use the top one or the bottom one? This is hard. I didn't even go over these yet. Do you think we're going to use the top one or the bottom one? Which Excel equation for number 2? Exactly why? Oh, can you guess? Well, good guess, but it's because there's a standard deviation is the second number. Well, down here, the second number is the square root of the percentage times 1 minus the percentage or proportion. Number 3, random sample of 60 taken from a population with a given proportion equal to 82%. Show you detailed work, determine the upper and lower control limit from Tuesday's equation or today's? Today's equation, because it's a proportion, right? There's no standard deviation involved. Well, I should add to this problem right there, and then give the Excel equation also. This says manually, but after today's lecture, you're gonna go, gosh, we should do the Excel equation for number 3 also. Just throwing that out there. 4, a production process designed to fill boxes with an average of 24 ounces of cereal with a standard deviation of 3 ounces. Show detailed calculations for the upper and lower control limit with a sample size of 12. Tuesday's equation or today's?
Tuesday.
Tuesday because? Standard deviation, very good, very good. 5, write an Excel equation using the Excel function competence to determine the upper and lower control limits for the problem above. Would that be this top equation or this bottom equation? Top because? Standard deviation. You guys are all over it, not real loud, but you're all over it. Now, hopefully that makes your homework easier, which is due on Tuesday in 5 days, correct? Only 5 problems, it shouldn't be bad. Now, here's how it's used in real life. This company says they have a production process with 5% defective rate. Their goal is 5% defective rate among the things they're making, whatever they are. Does it even say what it is? It's a production process of something they're making. The quality inspector takes 6 samples of 500 each, of whatever it is. And the following has come true. So while they're taking 500 samples 6 different times, they're calculating how many were defective of whatever this item is. We could even go with the ball bearing, the same thing we talked about Tuesday. The little ball bearings that are used in cars, and the wheel ball bearings or something. And so an inspector is taking 500, putting it through the machine. The machine's determining whether there's any defective or not. The first batch, if you look there, the proportion out of 500 that were defective, where's my pointer? I want to point at it, and I lost the pointer. There it is right there. 0.065, 6.5%. Don't forget, the goal is 5%. So we have to determine, is that in or out of the control limit, upper control limit, because that's above 5%. The second one was 0.075, 7.5%. Is that within the controls around 5%? The third one's 8.2%, then 8.6%, then 9%, 9.2. These happen to be in order from smallest to largest for some reason, or maybe this is exactly how it went. Let's figure out what the upper, these all went up. None of them are lower. So we can just do the upper control limit and figure out this. Here's how we're gonna do it. The center line is what the percentage that was expected, which is 0.05. Plus and minus, but we're just doing the plus. 3 times the square root of 0.05 times 1 minus 0.05 divided by, oh, is it 6? What's the sample size, 6? Yes or no? I hear a yes. I hear a yes. I hear a no. I hear a lot of silence. don't forget, the sample size always has to be how many that were in each of the batches, each of those trials. So it'd be the 500, because there's 500 being done each time. Yes, it was done 6 times, it could have been done 5 times, could have been done 10 times, but it's how many each time it took place. So in this case, it'd be 500. The square root of this whole thing, right there. There's your setup. It should look familiar. The homework you handed in on Tuesday was using the same standard error of the proportion. The only difference is now we're multiplying it times 3 and adding, subtracting from what we're calling the center line, the given proportion or given mean. Here's the math on it, right down here. There we go. The upper limit, control limit, is 0.079. The lower is 0.021. Go ahead.
No.
Oh, I'll answer this then. You just did your inspection. What are you telling the guys on production right now? Are you saying, good job? Should we turn off the machine? What should we do? What do you think you should be done? And why? Someone help.
Where's control the upper and lower control?
The upper, I have the pointer right by it. 0.079, you just calculated it right there.
Oh.
And the lower is 0.021.
You should tell them to stop.
Stop. Stop. You say stop? Why?
Because the numbers are out of limits,
Like how far out of the limit? Like way out? How many of them are out of the limit? What is the limit again? 7.9%? So anything above 7.9%? So trial number 3, trial number 4, trial number 5, trial number 6. 4 out of the 6 are outside the limit. They're up above the upper limit. This machine should have been stopped a while ago. We're probably already at a point to where we gotta start going through these items and finding the defective ones and getting them out of there and then replacing them with good ones, which is gonna cost us money. We should have done the inspection sooner. Let's put together a control chart. Don't forget the center's gonna be the 0.5%. The top line will be the 7.9%. The bottom line 0.2 or 2.1%. And here's the graphing of it. And as you can see, there are 4 of the dots out of the 6 dots that are outside that upper limit. And this process should be stopped.
Are you gonna ask us?
Oh, of course. Not only do you have to calculate the upper and lower control limit, but you may look at a picture of some trials. Let me show you a picture of some trials. Hang on. Whoa, right there. Here we go. So there might be 6 of them here. Here's one at 6.5%, 0.065, 0.075, 0.082, 0.086. And my question for you is going to be, should this production process be stopped or should it continue? And you're going to say, stop it. Stop it, stop. These are outside the range. This is too easy though, you guys. You should be able to get this, right? Here's the harder part. You get right here. But it's not gonna be too bad. All right, let's do this same problem now. Let's use Excel, why not? Let's just jump right to it. Okay, here it is manually, right there. And I wrote it right here. So we have it right there so we can see what's supposed to be done. Now we're gonna plug it into here, but here's the weird part about using confidence. Let me bring this up. Looks like this. Here's an example where the mean is 20, the standard deviation is 10, and the sample size is 25. So as you can see, it's been entered in, the mean is 20. Now this is going based on Tuesdays. This example is based on Tuesdays using the standard deviation. So 20, so it says 20 plus the word confidence, parentheses. Now notice the first number is 0.0027. So here's a big hint. If we're using 3 standard errors, that first number will always be 0.0027. Now, if you recall, I said on the final exam, I'm not going to try to trick you, that the problems will be using 3 standard deviations. If for some reason I was going to give you some tricky problem that was not using 3 standard deviations, it will specifically say, this company is not using standard errors, excuse me. This company is not using 3 standard errors, but using 2 standard errors or something like that. I'll be real specific. So now that I said it in the lecture and we recorded it, that could happen on the final exam. But I would be real specific. And so you would have to use this equation to figure out what that first number is if it's not 3. Now, how do we know it's 0.0027? Here's what I didn't put on the board. It's a nice bell curve. Here we go. Here's just a sloppy looking bell curve. All right. What's happening is 3 standard deviations. Here's the center. Let's say 1, 2, 3, 1, 2, 3. We're trying to find that first number has to be the percentage of the bell curve that's out here in the tails. Because we're trying to find the upper and control limits from the center. 0.05 is the center if we're doing proportions, and we're trying to find that upper and lower control limit, and the way to use confidence is telling it what percent's in the tails. Now my question for you is, this says that there's less than 1% in the tails of all this area under the bell curve if we're at 3 standard deviations, a +3 and -3 standard deviations. Those two, and that's why, if right now, if I were to put NORMS DIST -Z, which is -3 times 2, because you gotta have both tails. What we're doing with that norm S distribution equation is finding the area right there in that tail. But it's only this tail. That's why we're using a -3. We're finding that tail, because norm S distribution always finds the probability from any Z to the left. But we need the area in both tails, so that's why you put times 2. So if you did this norm S distribution, -3 times 2, you'll get 0.0027. And I want to make sure you get this. If I said to you in a problem on the exam, hey, this company doesn't use 3 standard errors for their control limits, they're using 2 standard errors. Think about it. Would this 0.0027 be larger or smaller if that number 2 is being used instead of 3?
Larger.
Larger, because the tails now are bigger. But the only thing you gotta do to find those 2 areas added together is just, instead of putting a -3 there, put a -2. That's it. And you found the correct first number to find the upper and lower control limit using Excel. That first number is the hardest part of today's lecture, so I'm gonna say it again as I go into a couple of examples. Exactly how we can determine that. Matter of fact, I'm gonna even change an example when we get to a proportion to where there are only 2 standard deviations, so you can see how we're gonna come up with a different number here. I'm not even gonna come up with a different number. I'm gonna literally put this equation in for the first number and just put -2 there for the Z. I'm gonna let Excel give it to me. All right, so here is, I just want to show you this part of the calculation. Equals norm S DIST parentheses -3 times 2. That's how this 0.0027 comes up. It's 3 standard deviations to the left and to the right, the area outside of it, the 2 tails. Now I want to make sure you get this, because this leads us right into our very last lecture on Tuesday, which is called confidence intervals, using the same Excel equation. But we're using it a little differently when we use confidence intervals. Very similar though. So this is going to lead us. What's great about today's lecture, Tuesday's lecture, today's lecture, and next Tuesday's lecture, is confidence intervals and control limits are most likely right near the beginning of DS302. So you'll be prepared for it. It'll be like kind of a review when you start out with 302, probably with confidence intervals, because that's chapter 8. That's where 302 starts, is chapter 8. So should be ready. All right, so let's get to another example. I'm going to go to number 42. Number 42 down here. There we go, right here. Okay, number 42. Random sample size of 500 is taken from a population with a proportion of 0.34, right there. 0.34. Let's just stop right there. We don't need any more information. Let's set this up. What's the center line on this? Tell me the center line. What's the given proportion? 0.34. 0.34 plus and minus. Here we go. 0.34 times 1, oh, that's sloppy. I know it's small, I'm just out of room here, times 1 minus 0.34 over, what was the sample size? 500. 500 square root, and all I forgot is the 3 right here in front. Because it doesn't say how many standard deviations to use, it says find the upper and lower control limit, nothing about how many standard errors to use, we assume 3. Make the assumption 3 if it doesn't say. You know it's 3, every homework problem it was 3, every example so far has been 3.
Can you show an example where it doesn't show 3?
Say
Where it
again.
doesn't- where it shows a different number?
Say again.
Can you show an example where it shows a different number?
Yeah, I'm gonna do it. Yeah, that's how that's where we're heading. So here we are with this one. We would calculate the upper and lower control limit. You wanna do the math on it? Don't forget, order of operations is crucial when you're calculating these. Start out in the parentheses. 1 minus 0.34, so 1 minus 0.34 equals, so there it is, 0.66. Is that right? Times 0.34 equals 0.2244. Now we divide by 500, the sample size, divide by 500, this is the order you should go in. Now you should square root. Now this is why we gotta go 5 places to the right from now on. 0.0004, what would be the next digit? 4 or 5? 5, 4, 5, if we're rounding to 5 digits. I'm gonna leave it at, what is that, 7 digits to the right. Now I'm hitting the square root key, so I'm right here, I did everything underneath the square root, now I'm hitting the square root key, then I multiply times 3, then I add and subtract. That's the order you must go in to get the right answer. So I'm gonna square root this, there it is, 0.021185, I'm rounding because the next one's a 9. Now I'm gonna put that in memory, no, I'm not gonna do that, I'm just gonna add it now. No, I'll put it in memory. Now I'm gonna add it to 0.34. Here's our upper limit. Upper limit is 0.36, so 0.36, I gotta go a few more digits. 118, does that sound right? 118, everyone agree? Now I'm gonna find the lower limit, again it's 0.34 minus, I'm hitting recall because I saved the number to the right. So this will end up being 0.3188. 0.3188. What's the next digit? 1 or a 2? And all of them. Okay, here's the problem. We have the upper and lower control limit. Look at B. Said the following samples of these of 500 each came out with 0.28, 0.30, 0.33, 0.34, 0.37, 0.39. My question is, should this production process continue or should it be stopped? Continue or stop? Can someone take, now look at, hang on. 0.28, 0.30, 0.33, 0.34, 0.37, 0.39. There's our upper and lower control limit right there at the top of the board.
Just stop,
Stop what?
because it's above, it has like 3 that are above.
3 of them that are above or below the limit.
Actually like, yeah, 3. 2 above, 1 below.
See that, everybody hear
no,
that?
2 below.
He's saying that first one, 0.28, is below that 0.31882, so that shows you it should be stopped right there. But the next one's 0.30, that's within, no, even that's below 0.31. The next one's 0.33, that's between the two. The next one's 0.34, that's between the two. The next one's 0.37, now we're above the upper limit. The next one's 0.39, now we're way above the upper limit. This process should have been stopped. There's the answer. You gotta calculate these upper and lower control limits on the exam, and then you're gonna get some numbers just like that, asking whether the process should be stopped or not. And this process should be stopped the moment you see it's outside the limits. Okay, let's use Excel. Hang on, let me get Excel, let me get it open, let me go right here. My question for you is, we're doing this problem right here, that we just talked about, number 42, but should I use the top or the bottom equation, top or bottom? Why? I heard 2 different answers.
Proportion.
Because it's a proportion, we gotta use this bottom one, because of proportion. So I'm gonna do it just like you see it on the board. Here we go, equals, center line is 0.34, 0.34. I'm gonna do the plus first, so here's the word plus. Now, we gotta do all of this. confidence, norm S distribution, minus Z. I'm doing it all the way as if, I'm not gonna assume 0.0027. I'll accept 0.0027 on the homework though, because you know that one's gonna be a 3. So if you guys wanna just do 0.0027 on the homework, I'm fine with that. And the exam too, why not? But if it's not a 3, you gotta do this and figure out what it is, or put this in for the whole equation in for the first number. It's up to you. But you gotta show me the work, how you got that first number. I'm gonna go ahead and put CONFID, there it is right there, double click on it. Now it says alpha, in this case I'm putting the equation NORMSDIST, parenthesis, -3, you gotta put negative number, parenthesis, times 2, comma. Now the second number, which would be the standard deviation, but we're using a proportion. So the part of the proportion is the numerator part, is the only part that goes in here. Do not put the sample size. Let me repeat that. We're not putting the whole standard error in for the next number. Just the numerator part, the square root of up here. The square root of 0.34 times 1 minus 0.34. That's the only part that goes in for the second number. So here we go. What is it again? SQRT 0.34 asterisk parenthesis 1. I should have put a parenthesis around after SQRT. I gotta go back. Not. Right after that T, right there, parenthesis. Now it's 0.34 times 1 minus 0.34 parenthesis. Now here's the weird part. You gotta put a second parenthesis there. You have parentheses around the 1 minus the proportion, and then a second set of parentheses because the whole thing's gotta be square rooted. So I gotta put a second parenthesis, and I'm gonna make this bigger so you can see it. I'm putting a second parenthesis there, then a comma. Now the very last number is the sample size. No matter which equation you're using, you're putting the sample size, which in this case was 500. Let me repeat this before I hit enter. Do I need a parenthesis? Yes. 0.34 plus the word confidence, parenthesis, norm S distribution, parenthesis, -3 asterisk 2 times 2, comma, the square root, parenthesis, 0.34 times, parenthesis, 1 minus 0.34, parenthesis, 2 of them, comma, sample size 500, parenthesis, if this worked out right, manually we got about 0.36118. This is gonna go more digits than that, but it'll be 0.36 something. What? What just happened? What did we do wrong?
You didn't multiply 3 in the manual equation.
Yeah, you didn't multiply by 3. And when you manually calculated it, you never multiplied the square root by 3.
Thank you. I gotta put the 3 right here. The 3's right in front. It's 3 times that whole equation. Oh, up here I never multiplied times 3.
Yeah.
Oh, burn. Fine, glad we recorded that. Let's use last year's lecture. So really, it's a lot higher. So let's go back. There's that one. Now watch what I'm gonna do to do the other one. I'm gonna copy paste, switch it to a minus. No, that's not right. The 3 should be there. The 3 is on the manual one, not this one. Hang on. Let me get rid of the 3. There. Here is our upper and lower control limit. Now, let me put this off to the side. Let me get to this question again. Everybody see the number? Let me get it off the side without it getting big. Hang on. See if I can grab it. Here we go. Put it down here. No. Put it up here. Right there. Don't make. I didn't get this. I'm gonna shorten it up. There we go. Now. Okay, here are the numbers. Right here where my pointer is. 0.28, 0.30, 0.33. There's our upper and lower control limit. Right here and right here, because we didn't multiply times 3 over there. My question for you is, should this machine be stopped or keep going?
Keep going.
Because all of them now are within that upper and lower control limit. Even the 0.28 is above that one. Even the 0.39 is below that one. Let's go over here now. If I subtract 3, 4, and add 3, 4 to both of these, then multiplying times 3 and add and subtract 3, 4, I should get the same answer. Let's see if that's true. So I'm gonna just back up and take 0.36, 118, take the 0.34 back out. Let's see if this works, right? 0.34 back out. Here's where we were before we.
0.34, not 30.
Thank you. Do it again. 0.3618, 0.36118 minus 0.34. Here's where we were. Then we should have multiplied times 3, and now add it to 0.34. Do we get the same number? 0.40, 0.4035, same number, 0.4035. So we had to multiply these times 3. Let's do another one. Make sure we got this. Number 43. Random sample size of 400 has a population proportion of 10%. What will be the upper and lower control limits? Let's go with Excel. Whoop, do not do it. I'm gonna do it right below here. Here we go. Equals. I'm gonna do this twice. I'm gonna do it as if we're using the normal 3 standard errors, and I'm gonna do it again as if the problem says this company is using 2 standard errors, so we can see the difference for our upper and lower control limit. I'm gonna do everything here. Just tell me what numbers I should be entered here. What should be the center line in this case? Says random size of 400 is taking a population proportion of 10%. So the center line is what? 0.10. I'm going to do the plus first. So plus confidence. I can just click on it right down here. Boom. Alpha. Again, we know it's 3 standard deviations, so I'm going to go ahead and try this time. 0.0. What is it? 0.0027. 0027. Is that what we have here? Go ahead, comma. Now the standard error without the sample size. We're doing this again. SQRT parenthesis 0.10 times parenthesis 1 minus 0.10 parenthesis. Now let me stare at this. Another parenthesis, comma, sample size, which is 400 this time. Parenthesis. Here we go. So from 10%, it goes all the way up to 14.5%. Does that sound right? Let me copy and paste this, but now make it a minus. And our lower limit's gonna be, let me switch this to a negative. 0.0, so we got 14.5% all the way down to 5.5%. Look at our samples in problem 43. We have 0.06, 0.11, 0.09, 0.08, 0.14, 0.16. Look at our upper and lower control limit. Now tell me, production process keeps going or stops? Who said stop? And why?
Because 0.16 is higher than the upper.
Exactly. Everybody hear that? 0.16 is higher than that upper limit of 14.5, 0.145. 60% is higher than 14.5%. The process should be stopped. The moment one of the samples are outside the upper or lower control limit, the production process should stop. That's the answer. What if you had to graph this? Could everybody graph it? Let's look at it then. Ready? I'll put it right here. Here we go. Here's my center line. This is going to be 10%, so 0.10. Here's my upper control limit, which is going to be 0.145. Is that what it says? 0.145. Here's my lower control limit, which is going to be 0.5055. And now, I'm just going to go, how many trials are there? There's 1, 2, 3, 4, 5, 6. So I'm going to go with 1, 2, 3, 4, 5, 6. There they are. Number 1, I'm just going to estimate where it would land at 0.06. Well, that would be just above the 0.5 and a half. So about right there would be 0.06. Then we have 0.11. 11 would be just above the 10, so I'm gonna go right about there, just above the 10. Then the next one is 0.09, that'd be just below the 10, so I'll put it right there, just below the 10. The next one is 0.08, a little more below the 10, so I'll put it right down there. Then we go what is that, 1.4?
Yeah.
1.4, well, we're going right below the 14.5 right there. And then the last one's 0.16, there it is. We connect the dots. There they are. That is a control chart. That one being above the upper control limit is the one that's telling you that you should be stating this process should be stopped. This production process should be stopped. This is easy. This is so easy. Operations management, you're gonna see this again. But you're gonna get more into detail.
Is the chart gonna be on the top, like you have to write it?
Possibly. But my question is, could it be on Thursday's part one, or is it gonna, or can only be on Tuesday's part two?
It can be on part one.
It can be on part one? Because why?
It's not on Tuesday.
That's right, this lecture's today. Only Tuesday's lecture, last lecture, is the only part that can't be on that part one final exam. Right? This part could be there, including the control chart. Oh my God, this is too easy of a class, so don't stress too much. Don't stress till you get to 302. Then stress. Panic. Go straight to panic.
Wait, what chapters are on the test again?
I don't know what chapters, but it was week 1 through 14.
No, not on the final, on the exam on
Thursday
Thursday.
is weeks 1 through 14, except for whatever's covered on that last lecture Tuesday. That can't be on that part one. Everybody hear that?
Oh, I thought you were doing it like, the last 3 chapters are on Thursday.
No, just Thursday can't have anything that was in Tuesday's lecture,
Oh,
but anything else is fair game. But in Tuesday's lecture though, I'm trying to come up with a list of items that I want you to not study, right? Did we talk about that? Yeah, so I haven't done it yet, but I hope I will. All right, this company said, hey, we have one problem. We're no longer using 3 standard errors, we're using 2 standard errors. We're using 2 standard errors. So now I'm going to this Excel equation, let me bring it up here. And I'm now gonna switch this first number, let me lengthen this out so we can see the whole equation. I'm gonna switch this first number to the Excel function norm SDIST. Go ahead.
What does it say that for two?
I'm sorry, say it again.
Standard errors. The 2 standard errors, where does it say that?
I'm making this up.
Oh,
I'm saying let's switch problem 43 to have only, let's say it says, and this company, pretend this is a final exam question, everything's the same as number 43, except it says this company doesn't use the standard 3 standard errors, it uses 2 standard errors. So with those words, the only thing that has to switch as far as using Excel, if you were doing it manually, the only thing that has to switch is switch that 3 to a 2. That's it. But as far as Excel, that first number in the parentheses, you're gonna have to either use the Excel equation or use the Excel equation, write down the Excel equation and give the number and use the number, whichever way you wanna do it. I'm gonna use the Excel equation, which is NORMSDIST. I emphasize that S on purpose. Now in the parentheses, I put -2, parentheses, and now multiply it, asterisk, 2. So this is saying, tell me what's in the tail of the bell curve from -2 to the left, that area, because we're using 2 standard errors instead of 3, which means it's gonna tighten up the center, which means this is a very important item, and that the upper and lower control limit need to be smaller. And we need to stop production if it falls outside of 2 standard errors instead of 3. So this number, 0.0027, is gonna be a larger number. But here we go. So what should happen is our upper and lower control limit, which was 14.5 and 5.5, I think, it's gonna tighten up. It's no longer gonna be 14.5. This is gonna come down to, here we go, to 13. And this one's gonna go up from 5.5 up to, and yeah, I gotta switch this. Here we go. NORMSDIST, parentheses, -2, parentheses, times 2. This one's gonna go from 5.5 up to, 5.5, it'll go up to 6.5, 7. 7, thanks. So now, because this company is using 2 standard errors instead of 3, let's look at the numbers again. If this company were to do this, where are they? 43, there they, someone know how to fix that? Yeah, let me put it, yeah, I'm gonna make it shorter so we can see them all at the same time. Okay, now I'm gonna move it over. Okay, look at the numbers now. In B, 0.06, 0.11, 0.09, 0.08, 0.14, 0.16. How many are trying to tell us now that this production process should be stopped? 3? Let's take a look. You're saying the 16, because 16 was before when it was back at 14, so 16 is way out of it. The 14 is above 13, so that is the 08's between them, the 09's between them, the 11's between them, but the 06 is below, so he's right. 3 of them are now outside the upper and lower control limits, 2 above and 1 below. Could all of you have come up with the new upper and lower control limits knowing that the statement says this company is going from the standard 3 standard errors down to 2 standard errors? Could you do it? Yes? We're all good? Because that was the hardest part of today's lecture. Well,
I have a
yes.
question.
I mean-
Are you gonna show us a question that was, asked for you?
I don't have a question I asked for to prepare. So I just took number 43 and pretended as if it said. But I would make it very clear. I would say this company's not using the usual 3 standard errors, instead using 2 standard errors. So I would try to make it very obvious. That make sense? All right, boy, are we excited? I mean, to have the class over, so I'm not good. Will I do an in-class assignment? Oh wait, here we go. I forgot, right here. That's right. Henry Kissinger just died, and probably none of you even ever heard who he was. And I think he made it to 100 years old. Here is what I think is the key to long life. Low to no stress. You want to create a life with low to no stress if it's possible. Low to no worries or problems. By the way, the theory is the less people in your life, the less problems. What? Someone agree with that? I know we as humans need other people, but I want to tell you, start shortening your circle as you get older, you'll have less problems. Less people, less problems. Can't emphasize that enough. You should be pursuing peace of mind, and then pursue happiness. These are the keys to long life. Rosalind Carter just died. Her funeral was on Tuesday. She was our first lady way back in the 1970s. Her husband, Jimmy Carter, was our past president, who's about to pass away. He's already in hospice. Hospice means they're giving up on the medication that will sustain life, and they're purposely ending life. And so we'll have one of our presidents, who you guys have no idea who he is. He will be passing soon. They were married for 76 years. That's amazing. I've never been married. I don't know why I said that. Because I'm using up time, because we're early. Are you ready for the in-class assignment? Oh, wait, I have one more thing. I know I've said this before, but I can't emphasize it enough. While you're young, when I was in college, I was really poor. Really poor. I mean, I picking up cans on the side of the road just so I could get to Burger King, to order the usual. I know you heard that before, but it's the truth. I will never forget it, because when they started saying to me, you want the usual, you knew you were poor, you're walking in getting the same thing. 2 cheeseburgers with just onions light. So, develop habits to stop wasting money at a young age. Right as soon as you graduate, even now. You stop for gas, don't go in there and buy a soda or a coffee or something in there when it's so much cheaper somewhere else. Plan ahead. Buy them at the grocery store, already have them in your fridge. By the way, does anybody pay their own heat, utilities? Do you live in your own place, pay your own heat at all? Not one of you. One person. Thanks. One person. I want to tell you how cheap I am and how I've developed the habits at a very young age to not spend money. If you walk in my house right now, it is 55 degrees. What's so wrong with that? What's so bad? I moved it up from 49. It's 55 degrees. Because there's no reason to have a whole house heated when you don't spend your time in the whole house. Yes?
What's the temperature in your house in the summertime?
I don't know. I hardly ever turn on my air conditioning. except in one room. The room I spend the most time in, I have a space heater. It's a comfortable 68 degrees in there, or 70 degrees. In the summer, I have an air conditioner in there. It's very comfortable there. The room in which you spend most of your time is the room you want to have comfortable, especially when you're sleeping. Sleep is a huge part of life longevity, having good sleep, which is also part of your peace of mind. It's having that solid sleep. Both, you know, the deep REM and the non-eye movement deep sleep. Both of them, you're bound as you start losing sleep as you get older. All right, that's all I got. You ready for the in-class? All right. This is your second to last in-class. And as far as homework, the homework due on Tuesday is your very last homework assignment that you have to hand in, correct? Right? Because we all know week 14's homework does not have to be handed in. I'll post the assignment on Monday, but I'll post the answers right after the lecture on Tuesday. Okay, so here we go with the in-class. It never gets old. Never gets old. Wait, for extra credit, could anybody name who the artist was on that song earlier? Who was it? No, that wasn't it. No. I'll give you a hint. He's dead as a doornail. Nope, not Jimmy Buffett. Good guess. Decent death, I like that. Okay. You ready? Production process is designed to fill wine bottles with an average of 25.4 ounces of wine and standard deviation of 2.5 ounces. Show your detailed calculations to determine the upper and lower control limits with a sample size of 36. Next, write the Excel function equation using confidence that would calculate the same upper and lower control limits from the question above and give the results. Meaning you gotta enter those in. The results you do manually may be slightly different than the ones used in Excel. Now, when you use Excel, it's up to you whether you want to use the norm S distribution or you want to put in just 0.0027. It's up to you. Because this doesn't say anything about it being different than 3 standard errors. All right, only one lecture left. That's it. We're at the very end. Feels like a party. Right here, okay.